Hey, this is another video here at Wolf Industries Inc. and I want to talk to you today about the houses we're shipping to Alaska. So shipping via barge out of Seattle, not just any part of Alaska, but this is Nome, way out at the end of nowhere. And then we're going to go 2 hours north to Teller. So some differences that we had to solution seek and dig in and figure out on these builds were centered around siding, a whole host of stuff, but siding, fuel source for the interior heaters, and a lot of other things I want to take some time and share with you today. So let's get started. With the siding, if we do traditional fiber cement, hardy, or Allura siding, like we do in our northwest region of Washington and Oregon, we're going to have issues with the extreme cold, because that siding, when it's cold out, it gets really brittle. You're dealing with subarctic region, and that blowing wind, expansion and contraction, that's going to end up falling off of the house with that brittle siding. So it's very important for us to go with a wood-based product. A person could go with metal for ease and usability. We chose the wood-based product, and that's going to be very stable in the cold environment. Another thing that we're doing with this house is we're going with a copper fuel line. You can see here below this masking that we're supplying diesel to the inside heater. Up there, electricity is so expensive, ran off of diesel generators, that they opt for just going straight to diesel. That's going to fuel your tankless hot water heater on demand, diesel fired, and a Toyotomi space heater in the central living area. Super critical. You can see here where we have all of the electrical outlets sealed off with spray foam. That's going to prevent any of the 50 to 100 mile an hour wind going through these houses up there in Teller, Alaska. Another thing, this is a house built with plywood walls instead of drywall. Super key, because when it's sitting on Tundra, we did not want to have that house flexing and moving, cracking the drywall, because we know it will flex and move. When you've got that Tundra, it's always freeze, thaw, permafrost going on. And we're going to set this house on jack stands and anchored down to the ground. No ability to pour concrete way out at the end of nowhere. So we're shipping the foundation with this house as well. And right over here inside the house, like we're talking, we got the Toyotomi heater set up for heating the entire home. That thing will put out plenty of capacity, plenty of heat, plenty of BTUs, keep this place cozy and toasty. In this house, we've got 2x8 wall construction with staggered studs. We did a thermal gap between them so that we don't have that cold transferring through to the inside. So this is a Arctic entry that we use up there on those houses. This is an exterior door inside the house. What will happen is they'll come in that main door over here, come in, and it's just like an airlock you'd have in a commercial building. Take off your gear, hang up your coat, put your boots down, and then open this door and come inside, saving and conserving all that heat as much as possible. And up here we've got a ceiling, again done with plywood, but we went with R50 in the ceiling. We did R30 in the walls. And for reference, a traditional home built to the normal energy code is hovering around R21. So this is over and above anything we've seen or done around here in the Northwest Washington. The floor is R50. Again, super thick. We used 2x12s, 12 inches of insulation down there. It's going to be one cozy place. It'll be exciting to get these set up on site with some completed pictures for everybody to see. So another interesting thing when we have really cold climate is we want to send individual supply lines to each fixture throughout the house. Right here we have them tied together so we don't have any issues during shipping and transport, but they'll snip this, and this is a supply line, let's say for the lavatory or the kitchen sink on this half of the module, or the module that sits on this half. Get on site, connect them together, and away you go. Because it's not if, but when you get one of those fixtures frozen, you want to still be able to use the rest of them inside your house. Right here we've got the 2x8 wall construction giving us that R30 of insulation that we can do in these homes. As you go down the wall, we've got 2x4 walls separated by ½ inch gap. Well, it's more like a 1/4 inch, but it allows a thermal break just as long as they're not transferring cold from the outside moving to the inside of the house. very key. This place will be very warm in the wintertime. Right above my head here, you can see that we've got a vent system for the attic, because if we don't have a special unit like this, we're going to end up with an attic filled with snow. So it's known to happen there in the North Arctic, where you got that consistent 50 to 100 mile an hour winds, bringing the snow with it, going in up over the eaves, and then just filling people's attic entirely with snow. So this one's all sealed off, and this acts like a snorkel. Air has to go up, over, and then down. So very important to pay attention to the details and ask and know and understand what goes into your region of housing. So thank you again for watching and following us about what we've been up to. This Alaska project has been a kick in the pants, and look forward to talking later on the next video. Subscribe below. As always, make comments, and we'll talk to you on the next one.